It's a C drive users. This one here, and then sources, repos, F64, debug, and there we have it.
I should click on the document.
Okay, so when you build and you have 100%, like 1 succeeded, 0 failed, it means that you have created an executable file. Let's assume you write a piece of malware in C. The file you create is now executable, which means you can send to somebody, and if they click on it, it will run and commit the harm. In our own case, it's simple arithmetic that will just add 1 or 2 different numbers. Now, in previous cases, we only see the .exe file, right? But because we built it from scratch, we can then go and find the location where we built and saved. And automatically, this includes what I always call the PDB. The PDB will know the name of every function the programmer used when they wrote the code, which means it's easy for analysis. In our previous cases, we never had the PDB file, which means names of functions are saved as subroutine and the address of that particular function. But if we have the PDB, because we built ourselves, it will resolve every function name to the correct name the programmer used to write that piece of code. So let's see the location. Is this VisualBox on your real laptop? Okay, so I know if you go to your computer and you go to this PC and C drive, and you go to users, so go to your computer, C drive, users, under users, for him is Akasa, and then you have source. Also, that was why I told you, remember the extension where you save the project, because that's where you can go to find the PDB file and the executable file. So we have sources, and then if I click on the sources, it now gives me the repos. Remember the repos that we saw before? So I click on the repos, and now I have class, and under the class, now students select x64. So x64, and then select debug, and then you have the class, the exe1 is built, and also the PDB file. So for the first time ever, we have the PDB file as well. One more time, go to the C drive, go to users, the place in case you have multiple users, remember where you saved it at the start of the class. And then from there, you go and see the whole extension. So you're looking for source or sources based on how you saved it, and you have repos and whatever you saved it, and select x64. You can have multiple options. It's not always just x64. Select x64 and then select debug, and you have, we care about these 2 files. So this file is the class, and automatically it is now executable, which means if we run this file, it will execute the code we created, which means if we build a malware, automatically it starts to work. That is why Visual Studio is very important to us. In previous cases, we have to compile, do this, do O file, do this, and create a system, right? Now we do automatically at one go, and we have all the files. So what I want to do is to actually examine this file. We can test this file. If you just run it from this environment, it may not open. So for me to make it work, I have to click on it and open in terminal, right? How do I open in terminal? Okay, let me try this. I think I'm getting old. Okay, CMT. Okay, I managed to be clever again. So, if you run this file, that the exe file, it will not work. So what you will do, it works mostly on the command line environment. Remember, I've told you before, the command line is deadly if you're doing malware or you're doing cybersecurity, because most people will not have access to the graphic user interface. They will use command line to run, to do all sorts of things. So here we can then run the class. And see, it says total equal to 3, which means our solution is built and it's working. Imagine if it's a malware, it still works. So now we have it, and we can then put it in a debugger to see how it appears like the previous cases. Anybody got 3 also?
No, how do we open it?
So for you to go there, students, I'm very lazy. You can go and type the entire path to the destination. But I can go there, do my shortcut, and put CMD, and it takes me there, and I just run the file. In some cases, you can use /, and the file name, the extension of the exe.
CMD.
Yes.
يرونة الأسمدي
Yes.
تفتحي الأسمدي وتحطين الباث.
So look at the path, and that's where you're going to find what I just did now.
Okay.
And you can save the result.
CMD as administrator ولا عادي؟
Oh,
عادي عادي.
Yes.
أقول CD رقم حقي. صح؟ Yep. I go, what do you want to run? Which file?
The bottom one.
Oh,
That
yeah.
one is
PDB?
لا الفوق لا.
متأكدة؟
You will go.
And then new item.
لأن سمعتها قالت شيء PDB.
And then save it as
Do we run the PDP?
I'm not sure. They put the command below, but I didn't understand what it was.
Doctor,
Then you can type the code there.
Doctor, which file do we run?
PDP or the
Or the PDP?
Yes, no, not the PDB. You want to run the one without the one that looks like an exe file. If you just click on it, it won't open, it won't give you anything. So you have to go into CMD to do it.
And
So
doctor, how do you open it?
just write the file name, Sarah. Just
Only
type the
that.
file name here
open file copy path.
and press enter. And you have the result there. Which means you build correctly and it's working.
Wait, how we do it?
Okay, so enough students have built and they have the result, which is equal to 3, so I can move on. So luckily for me, because I became stupid and deleted my Visual Studio this morning again, I have to go and, because I've already done this several times, I can now go to the real part of the class today. So now, on VisualBox, I can stop you now, I don't care anymore. So, in my own case, because I've done it this morning again, if I go into my... So, in my own case, students, now you can follow me now. Hopefully the one I did is still there. So, if you go into this PC, in my own case, Windows 10, and under users, that's the location where I save my repos. Under users, and then ID user, and you can see here sources or source. And I have repos, and I have BUB 2025. So, see, any of you got things like this in my own case. I have more things that are built into it. Some of you may not have all these things. But for me, it built all sorts of things. And what I want students is the one on the X64. It also includes my source file. Can you see? The one I want to look for, the executable, is under the X64. So now I have debug, and obviously I have the 2 files I'm looking for. So the one you mostly see, like in the assessment, you only get this one. Do you see now? But now you know how you can make, let's say you're doing a malware, you know how you can make the malware and make it executable, which means you can run the malware and to behave the way it wants to behave. Okay, so what I want is to copy this one. I will just copy this one into my malware area because I want to analyze it. I will just put it here.
Wait, what did you do?
Because I want to use debugger to check how it behaves. Students, in this case, we know exactly what is the code we wrote, right? Let's see how debuggers will treat this as if does not know who wrote the code. Okay, so now we want to use either. Our plan for today is to use either. Students, thank you for understanding my behavior today. My laptop betrayed me. I insulted what's her name for too long, and it backfired. So, I don't know, some of you can be more smarter than me. Please, if you can get a more recent version of IDA, I will appreciate that. They told me to pay, and I don't want to pay. I used to still free software as a student. Now I can't pay for software. They said either is free, but you have to sign in it. Now they're asking for money. Nobody wants to pay. But either is very good. I know they have a new version like 9 point something, but I refuse to pay. So until then, I will stick to version 7.7. So now, all of you now, you can now follow me and click on our beautiful Mona Lisa of the IDA freeware 7.7.
Can I move the Visual Studio to
It's already,
maybe?
it's already
Okay,
inside.
so when you click on
It's
IDA,
already inside the soft.
because
the
I've done
folder
so
that
many
has
things
all
on IDA, you want to click on new file.
any years.
So click on new file, and then we can go and find the location of the file I just created. So see the one I just made today is bub2025.exe. Remember students that the one we built, in your own case it may not have .exe. It's the same thing. In my own case, it's bub2025.exe. So I simply double click on this file. And now we can then analyze this file. So this is how we make the assessment questions for you. This is the step-by-step way to build the whole assessment task for you. Now you understand how you can build your own solution, because the analyst only gets the .exe file. It doesn't have the entire process of how they wrote the program, how they built it, how they compiled, how they saved it, all the extra things that come with the file we created. This simple line of code we wrote is now something different. So what I will do, anybody here with me? Anybody on IDA right now? So load the program on IDA, let's analyze together. So on IDA, I want to simply click OK, and then see. What do you see? It says that the input file was linked with debug information. And because we are the ones that compiled, it means we have the PDB file now. In the assessment, you don't have those files. In real life, you won't have those files. So I can do two scenarios, one where I load, because there are two files in the folder, one with PDB, one with the executable. So I can do both of them, I can see the difference. So for now, let me do without this. Okay, our program starts. Anybody here with me?
Yeah.
So what did you notice? Automatically, look at the left-hand side, the functions, and compare to the simple piece of code we wrote. We wrote a simple piece of code like this. So how did IDA come up with all these different function names? We did not give any of these function names. That is what you see when you analyze any piece of code or malware. The debugger looks at the piece of executable. It does not know what is the PDB, so it does not know the name of the function the programmer used. In that case, it replaced every function with the location, the address of that function, and they use subroutines for that. Let's say I include the PDB file, it will have known the names of the functions. This is why debuggers always give this kind of result when you do it. So students, if you have this small screen at the top, you can see that the first thing we see is a public start, right? Which means that the debugger needs to know where the operating system needs to know where it jumps to start to execute the code. The entry point is very important. It is not always the entry or the start. We have to find a way to know where is the entry point. How can I know that? If I use tab, it now converts what I have into the text view. In some cases, the text view gives you a good understanding of the program. If you have a much bigger program, then the graphic view gives you the flow of information or the branch. But because we have a very simple piece of code, I will use this view. And why do I love IDA? IDA gives me all these multiple subviews. Students, if you don't have all these subviews like me, it's simple. You can add all the subviews. You can come to the right and go to view, and you go, it says open subviews, and you can click to add all the subviews. In case you don't have all the subviews. So the first thing I want to do as an analyst, remember, now I assume that I don't know who wrote and compiled this piece of code, even though we've done it together in the class. Because in real life, you don't know who wrote the code. So what do I want to do? I need to know the entry point of this. So on IDA, it's very simple. We can check export and import. It's so easy for me because if I go to my export window, see the starting point, and it says the main entry. Anybody have something like that? Okay. We need to always know the entry point because the operating system needs to know where it can jump to start to execute the code. So once we know the entry point, we can go there and see where the program starts to function. Okay, and because one more thing about IDA, IDA is interactive, which means I can click and follow. Be careful to always follow what is called a cross-reference. X-reference are very important in analysis because it will take you to different locations. I don't need to know everything. I can follow the cross-reference. It will lead me to the correct location. So if you have the import, it says, and look at the address. So now at least we know the location of the entry point of this program. Students, it's not always that it says main entry. It may have different names, but the export will tell you exactly where the start of program starts. We can look at imports again, and now you see the magic. We wrote a simple program, but now it imports all these different libraries automatically when we build the solution. So all these libraries are part of what comes automatically once we build the solution using our Visual Studio code. Okay, so if I look at this place here, I will have an idea what is going on here. And I will leave this place again. The next thing I want to see is to look at the different IDA view, which is the main point. And here, I need to find a way to know where is the entry point of this piece of code we wrote. Remember, we know the code we wrote, but now it looks different from what we wrote. Again, there are other views. So we have the hex view, we have the structures, we have the enum, and other things. So now, I'm looking at the left-hand side. Students, who can pinpoint where is the entry point from all these different functions? Remember that we know exactly what we wrote. So who can tell me where is the entry point on the left-hand side, on the list of functions? And if I can't use that, what else can we use to find the entry point?
You said exports.
Huh?
You said exports.
Yeah, we can use the export, but in case you don't have the export, what else can we use that we talked about every class that follows something? The strings. So let me go and open another view and go to the open sub views. And I go to, if you see the strings, let me know, okay. Strings. So when I open the strings, I will make it a bit bigger. Okay, so if we look at the strings, what can you see that has a slight resemblance to the original code we wrote in C? Anybody can spot something?
Is it the D?
Thank you. So only total is kept. The rest is now damaged. So we can find the total. So our only clue is the total. That's what I want from you students. If you can do this every week, my job is done. I go home smiling. I've done my job. Our only clue is total. So you remember the total, the debugger kept only total, and the rest of the functions, we don't even know what they are. What does it tell us? We can go to the total and click on it and then follow the total to know the entry point. So now you see multiple ways to find the entry point of the program. Let's double click on the total now. So I will let you lead me right now. So if I double click on the total, sorry, not there, we are looking for the IDA view. Okay, so students, please click on the IDA view A so you can see what is inside the IDA view. Okay, so students, what should I do next? Who wants to be the teacher today?
You want to look at the X reference?
Yeah, before I click on the green, what have you noticed? Look here, we see the first entry of total. But this entry of total is under the data section. Can you see? We can't analyze in the data section. we're going to analyze the text section. So when we click on the total, it takes us straight to where the variable is stored, which means we can see here, and again we know the address. Can I make this bigger? Who is my? See, if we have arrow data, we can't analyze. If I click on my, what is it, tab, it won't give me the graph. It's useless. So what do? It gives us the sub-reference. This is very important to us. So the data section is like pointing to the exact location where the code is used. So now we took a clue from the strings, and then see here, we have the data reference. So if I click on the subroutine, it now takes me to the text section. Anybody there with me now? Anybody following now? Ahmed Al-Haddad Al-Hamad. Are you following? Are you here with me? Yeah. Anybody else? Al-Hanif, are you following me again? Or you are lost? Anybody still following me? Al-Alawi, are you following us? Anybody see this so far?
Yeah.
Okay, so look at the section here. So without doing anything, look at the first instance where total. Oh, it's added small a. So either came and said small a total ID, but it kept the string. Why did it keep the string? Because the string was put in the printf function. So it says a total d, and of course the actual string. So what can we do from now? We now say that, okay, it means that from here to this part is the entry point, or where is it? Have I lost something?
From the subroutine to the
Okay. So this is the part of the program where the code we write is being executed. Now let's compare this to what we have in the manual. Remember, all of these things I have here, they are from the book, the practical manual analysis. So let's see. And remember, students, I will pause here for a second, and you can tell me why we have D word and this. Why do we have these things? Why is int x, this variable named like this? Who can tell me? Why is int x renamed as D word and the address?
because of the offset in the stack itself.
Huh?
Because of its address in the register or the task or the stack itself.
You can rephrase in a better way.
Yeah.
Anybody from yesterday's class also?
Like it's a pointer to the stack.
Not really.
It's address.
Why is the address, why is the variable renamed as D word and the address name? Is the correct way? So because it's declared the variable maybe in local or global variable. Huh? Not really. So the question is more if you declare the variable either local or global. There are two ways that they will appear on the debugger. So if the function or variable, so in this case, look at the variables, they are outside of the function, which means they are global. If you have global variables, automatically they rename them as D word. If you have local variables, they become a pointer. So students need to know when you see D word, this D word translates to int x. And the next one, let me go back again. So we can compare this. So in my own case, let's compare. Sorry, let me try to move this one. So in my own case, I have the first D word. So it's D word 14. Okay, it's a different address. Anybody got something the same as this one on the material, or you got similar to me? So even though you have to be different, you now understand what happens inside. And you can translate each of these lines to relate to the actual things we wrote in C. Students, what have we learned? That the simplest things appear like this. And to the person who is not in this class, if they look at this, they have no clue that it means int x, int y, and just to add two things. That is why when you get a job, you will get good money. Because you can spot all these things and you lie to them. You can take extra 1 week to do it. And they will think you are very smart. You pretend like Faisal bin Jassin, like you are smart. Okay, so students, now we know that the procedure is near. And again, the cross-reference takes us back. So again, we can analyze this part of the code because we know assembly. We can look at it and say, okay, look, who can remember this part? Students, who can remember what happened from push, and all these ones? So we prepare the stack for something, and then when we are done, we pop, which means from here to here is where our code was executed. Again, because I love IDA so much, if I click on this, IDA automatically changes it into a much better graphic view. And I can include the addresses. So now you see how it appears in assembly. We can try all the different listings to see how a program, a simple one like add 1 plus 1, translate to something this big. And our job is to spot in this entropy where is the toad of truth. Because if you don't know what you are doing, we have different functions here. And you can waste your entire life trying to find every function. They are not relevant to us. We need to know exactly what function or where to start. It's difficult to know how to do it. You need to have a high IQ to actually predict and say, maybe because of total, like you told me, you can start from there. I can make a mistake now. Let me say I don't know total. Let me just pick something else. It will mislead me. I can spend hours doing rubbish. That's when students say, doctor, I work very hard. Why did I get this mark? You can work very hard, but you're doing rubbish. The cleaners work hard more than me. I probably earn more than them, I don't know. But they work hard more than me in real life.
So like basically, if we want to like find something suspicious, like start from the strings, right?
You can try from the strings, you can find different locations. But for me, strings are a lot easier for me to use.
Yeah, because functions, they don't have the names, they have the offsets.
The strings are much better for me. All right. Students, so because of the way my computer behaves, I did not compile more examples. In the real way, we will have tried all these different listings. So we have like, okay, we've done this one. We will have tried this one when they are local variables. And the same piece of code, the only difference is that the variables are now declared inside of the function. And automatically, it appears in a different way. Okay, what else can we do with IDA? IDA is very interactive, which means we can use the search function here. So at the bottom, we can search our total. So you can search, for example, if I click on the strings, okay. So if I click on the function, I can search for a function. So, in case you try to find the entry, if you are lucky, you can come here and search, is it entry? And you may find that a function is there. In our own case, it says variable entry is undefined. So, let's see. If I type, because I've seen start, and for me to prove that the IDA search engine is working, let me type start. So if I type start, so I'm trying to use the search function on IDA. Oh, sorry, I was making a mistake. So you right click on, let's say, strings or function, and then you have time, you can say start. And okay, so that was my mistake. I was typing in the wrong environment. So what we can do to refine and save time, we can go see because I type or I searched for start, it gives me the options for start. So if I click on this now, it takes me to the start again. So let's say you use DIE and you find a string. Then you can come to the string section and then you can right click on this and you can say quick filter or Control F. And you can use total again like this and we have our total. So now I'm giving you shortcuts on how to try and refine when you're looking for something. Because we cannot go and look through every single function one after the other. It's impossible.
You fix your issue. Mine is not like this.
One more thing about IDA. Sorry students, so like I've mentioned, this semester is dynamic analysis, which means we can alter the behavior of the code. We can force the code to do certain things. So going forward, we can edit what is inside the code. The other thing again I forgot to mention, once you confirm something, you can rename it with the actual name. So if you have a subroutine, one fold, whatever, it's something like this, you can put the real name of it. That way it becomes easier for you when you analyze the program.
How do we know the real name, or we like create our own name and add?
So that's a good question. So how do you know the real function? You may not know the real function, but you can have an idea what the function is meant to do.
Also, you just call.
So remember the first we're going to do exit function or to write to something. You can say, okay, this is like an exit function, which means it's exiting something. So it doesn't have to be the perfect name. You rename it to what you think the function is doing. So if I hover over the subroutine, can you see, if I click on it now, it tells me what is happening here, and I can have an idea what it's meant to do. And I can rename this function to what I think. So it's more personal to me. It doesn't affect another person that uses the program. That way I can remind myself what I'm doing. Students, is this interesting for you or is boring? Next week, we are going to analyze malicious C content. So we can see, how do we know that something is malicious? How do we know that something does not look right? So the task for next is for us to look at some C programs and spot why we think this is malicious. I think we've had a long day today. We can stop here. If you have questions and you need help with doing this, I'll be there waiting for you. Yes?
So basically, my question is, this is the code of the function that we wrote.
Yes. That's how we translate in assembly.
Oh, like, where did all the other codes come from?
That's the point. So when you build it,
Yeah.
when you compile something, automatically it adds extra things.
But it's irrelevant to the
Irrelevant.
function.
Most of them are irrelevant to us. So that's why they trick you. You'll be spending your time looking at useless things.
Like
And the real code is maybe somewhere very simple like that. So if you can't find the code like this, let's say there's a malware. We can have 1 million lines of code, but we need to know where the malware is doing something.
Yeah, it's like
that
there
will
is
harm
only
us. That
3 to
way
4 relations.
we can alter the behavior. So trying to spot the class today is to understand how things appear. Because in the assessment, we give you the.exe and you just run it. But now you write yourself, you build it from start to finish. And you understand why does it appear like this. So we did not include all those things. We didn't add all those extra functions. Where did they come from? That's a good question. We don't know where they came from. And they are meant to trick us into just wasting our time. And we need to know exactly where to go and find our tool of truth from the so-called case. Okay, students, like I said, my laptop betrayed me today. Next week, we are going to do other things. So, going forward, remember the 6 internal sources we downloaded. Those ones are very important to dynamic analysis. Things like Proc1, Autorun, those are the things that we can use to catch the bad guys.
So what's the problem?
Autorun will go and search every single file that autoruns on your machine. And if there's a malware hidden somewhere, you can know from there. Without auto-run, the malware can be persistent and we have no idea. Proc1, all those tools, registry editor, Redshot, we can start to build up towards dynamic analysis of malware, where we can make the malware to run and we observe the behavior of the malware and have our definite answers.
Doctor, the only operating system we're going to need for this semester is MS Edge. Understand?
In most cases, Windows, this one is fine in most cases.
Only.
Not only, but for now.
But we'll use Wireshark and Fedora.
Yes, we can use them. So for this semester, what we need most of the time is this Windows 10. There's a very big class towards the end. All we're doing now is a bit high level debugging. There's what is called kernel level debugging. That's the most dangerous debugging. And for us to do that, we need 2 separate computers to do that. So that's not going to need. But for now, Windows 10 is enough for us. Towards the semester, we can use 2 separate ones because in this case, I can stay here and debug a file. But for kernel, you can't do that. You need to use this one to debug that laptop or that machine. Because kernel level comes to the hardware directly. So there's a malware at the kernel level, the machine itself can't debug itself. Because you have to pause the machine. Which means we pause this machine, use that one to examine this machine. So we need 2 laptops to do that particular one class only.
So we can't use 2 virtual.
Yeah, that's right, you can do that. But in real life, you can't debug yourself at kernel level. But you have to pause what you are doing. And by the time you pause, that means you have crashed your laptop. But that's not for now. Yes? You can uninstall Visual Studio for now, please. Uninstall it. We are done. Uninstall Visual Studio.
You just use it for this class?
It's just for this class. If you want to do, it's too heavy for me to keep it. For me, I always uninstall it. If we need it, we install it again.